This is an invention that I've been working on basically since the first lockdown. It's all to do with energy and being able to use kind of gentle sources of energy that are all around us, rather than focusing on very intense sources of heat as we have done historically with fossil fuels. And the aim is, rather grandly, to help make a transition towards being able to use renewable energy. And the reason for that is that this can be used either from a source of heat which might occur naturally, like geothermal, or it could be compost, or it could be solar power, something like that. Or it could also be stored energy from wind power or whatever other source where you maybe use excess electricity to heat up something, water in this case, and then get it back as electricity, or some of it, later on when you need it. It is quite a simple idea, so I would be quite surprised if it's actually new, but maybe Archimedes knew about it and then it's kind of been forgotten about while we've had access to oil and coal and all these very intense sources of energy which have been so convenient but which are now causing a lot of damage. So maybe it's just a reminder, or maybe it's actually in use elsewhere and I just don't know about it. That's quite probable as well. So what it is, I'll stop blathering on, is just an ordinary steam turbine, really, a tiny one, obviously. But it's all sealed up so that essentially you can put it in a vacuum. And the reason for that, as most people heard, that if you boil a pan and you're on the top of a tall mountain, the water will boil at a lower temperature. And so having it sealed up means that I can use this old vacuum pump here to suck out the air from this loop, which goes round, and it has the little turbine in it. And there's the boiler, you could say, in this bit inside, and this is a tank full of hottish water. It's 66 Celsius at the moment, and the point is that should be hot enough because of the reduced pressure for the water to boil and drive the steam turbine in there. The turbine itself is just a little computer fan, which I put in there, and it's connected up, the wires come out, and it's connected up to these little lights here. So, I don't know, I think I've kind of said the gist of it. So this is the big reveal. I'm hoping that this will work. I don't know if you want to see around here. You can see that this is the pressure gauge. Is kind of pretty low down. It's at about 98% vacuum, if you wouldn't put it like that. So suck 98% of the air out of that loop. So it's fairly low pressure. So I'll now turn it on and see if anything happens. So you can hear it spinning round, and the lights are now coming on. So it just functions as a kind of a battery, really, and it's sitting there now generating electricity from the stored heat in that water.
Can I ask how you got the heat in the water in the first place?
Yes, we used electricity. It was from renewable sources, though, because Ecotricity, we're one of their top customers. So,
but that could have been warmed up by the sun.
Yeah. So in this case, this is the most expensive electricity in the world, probably, because we've actually heated this water with electricity. But the point is that to get it to 66 Celsius, you could have done that in any number of other clean ways. So you could have used, I've had this running on compost, you could have got it from geothermal, it could be waste heat, it could have been, what else could it have been? I don't know, anything which will get the water up to that sort of temperature. So we're only talking about something that's a bit too hot for a bath, but not hot enough for a cup of tea. So it's not a high temperature that we're talking about.
And will it work at lower temperatures than that?
Yeah, this one will work at somewhat lower temperature. We had it running at 57 this morning, but that's about where this kind of cuts off. But that's a question of design, because I've made this out of bits and bobs that were lying around, computer fan here, a bit of bent pipe there, tin cans, so it's only to show that it works. I think that if I can make it work this well, then others can probably make it work 1,000 times better.
What would you think the lowest temperature you might be able to achieve and still boil water?
Well, I suppose if it's got water in it, which is a fantastic inert thing, then the very lowest might be about 25 Celsius, because I think that's like the lowest boiling point of water.
Body temperature, so
yeah,
a room full of people.
Well, I've had it running. I've had it running at less than body temperature, just not generating electricity. So I think the lowest is 29 Celsius, just spinning the fan around.
The lower it goes, the temperature, the more applications there are for waste heat.
Definitely, because we're all surrounded by those kinds of temperatures. You do need you can see it's actually dropped that. I guess that it's actually cutting out there because this bit's warmed up, or because it's fairly leaky and the pressure's probably risen, but you get the point of it. So it is still generating, but you can still hear the fan whizzing round, but it's just not quite enough voltage to make those lights stay on at the moment.
But that, in a way, that doesn't matter, does it? Because if you can produce endless amounts of small amounts of energy, that's almost as useful as big amounts of energy made quickly. It's the same sort of thing.
Yeah, if they're clean and possibly very low cost, then you don't need to maybe focus, as we have in the past, on very, very intense but polluting fuels or sources of energy. Maybe it is time to think about the lower level energy, which we all actually rely on, because if it weren't there, we'd freeze instantly. All life relies on that background energy. But maybe now's the time to look for better ways of using those gentler forms of energy which are around us all.
So in theory, it could just run constantly, could it? Just
as long as there's a temperature differential, then yes, in the range, in the working range of, here it's of water, so you need it to be somewhere between realistically between about 30 and anywhere upwards of 30 Celsius, and obviously the temperature around it would have to be lower than 30 as well.